So we all know what a fraction is. And one number divided by another, or one expression divided by another expression. But a complex fraction is one where you have a fraction within a fraction. If you Google complex fraction and if say went to Wikipedia, you may see fractions that are extremely scary. So we're not going to do anything, very scary, but we're just going to do simple complex fractions. Why do we call, the fraction that you see a complex fraction? We call it a complex fraction because I have a numerator and denominator, which makes it a fraction, but the numerator has a fraction in it. The denominator has a fraction in it. So we have numerators containing fractions and denominators containing fractions, and then we are dividing them. So things are getting complex, hence the name complex fraction. So what is the key to solving such fractions? I always suggest that you take care of the numerator and denominator separately. And once you have simplified, so the next step would be simplify. And the last step would be flip and multiply. And if at all possible, if you can simplify it further, go for it. So let's see if we can go through the steps. So I'm going to start with the numerator, which is 1 plus 2 over 5. And we all know how to combine the terms. We have to find a common denominator, which is 5. So I'm going to multiply the 1 by 5 and divide by 5. So I have 5 over 5 plus 2 over 5. The common denominator is 5, and 5 plus 2 is 7. The denominator, we have 2 plus 3 over 5. I can multiply and divide by 5, so the first term by 5, so that I get a common denominator of 5. So 2 times 5 divided by 5 plus 3 over 5. We have a common denominator now, so we just add the numerators. 2 times 5 is 10, and 10 plus 3 is 13. So 13 over 5. So what is the final answer? Now that we have found the numerator, the denominator, nothing much to simplify further. So we simply have 7 over 5 times, flip and multiply the denominator to the numerator. So 5 over 13, the 5s would get cancelled. The answer is 7 over 13.
Professor?
Hold up. So the numerator, we have 2 plus 1 over 7. I need the common denominator of 7, so I'm going to multiply the 2 by 7 and divide by 7. So 2 times 7 over 7 plus 1 over 7. I have a common denominator, which is 7. 2 times 7 is 14. 14 plus 1 is 15. So we have 15 over 7. The denominator we have 3 minus 4/7. I need to get a common denominator of 7. So I'm going to multiply and divide the 3 by 7. Have a common denominator now. 3 times 7 is 21, and 21 minus 4 is 17. And the last step is to take the numerator, flip the denominator and multiply. If I flip 17/7, it would become 7/17. The 7s would go away and I'll have 15/17. So the problem that we have here, which has an expression, x over x plus 2 divided by 2 over x plus 2, and it might look pretty scary if you're not able to isolate the terms properly. Here is the key: numerator over denominator, first fraction, and draw a bigger line and write it this way so you can see things better. But if you're able to recognize it just by looking at the problem, great. But if not, draw a bigger line for the fraction. So which is why here there is a bold line indicating that we are dividing one fraction by another fraction. Here we have nothing to simplify, nothing to combine. All we have is a fraction divided by another fraction. So we are going to directly keep the numerator, flip the denominator and multiply. So the denominator here is 2 over x plus 2. If I flip, I'd have x plus 2 over 2. Those two terms would go away and the answer would simply be x divided by 2. So now things could get challenging because sometimes people would know what to multiply by, but some can recognize it right away. So I'm going to take the usual approach of tackling the numerator and denominator separately, then combining at the very end. So we have 1 over y plus 3 over y squared. Now, the first thing is to obtain the LCD. The LCD of y and y squared is y squared. So I have to convert the first denominator, which is y, to y squared. So I have to multiply and divide by y. 1 times y divided by y times y is y squared. Denominator now, so I just have to combine the numerators. So 1 times y is y and plus 3. Moving on to the denominator. So we have y plus 27 over y squared. So y by itself is the same as saying y over 1. So I need a common denominator of y squared. So I've got to multiply and divide the y by y squared. So I would have y times y squared over y squared plus 27 over y squared. Now that would give me y cubed plus 27 divided by y squared. So I have the numerator, I have the denominator, so I flip the denominator, multiply to the numerator, so I have y plus 3 times y squared divided by y squared times y cubed plus 27. The y squareds will get cancelled. We'll have y plus 3 divided by y cubed plus 27. And most if you might say, okay, that is the answer and we can stop right there, but there is an extra step that you can take to simplify this further. So if you recall, we have a special product, a cubed plus b cubed is simply a plus b multiplied by a squared minus ab plus b squared. In our problem, a is y cubed and, excuse me, a cubed is y cubed, and 27 is simply 3 cubed. So we have a and we have b. So I can rewrite the denominator as a plus b, which would be y plus 3, multiplied by a squared, y squared, minus a times b. In this case, it would be 3 times y. So minus 3y plus b squared. B is 3, so b squared is 9. Those two would go away, so the final answer is 1 over y squared minus 3y plus 9. This is one of many reasons why special products are quite important. Oh no. So the numerator, we have 2 over x plus 3 over x squared, and the LCD between x and x squared is x squared. So I multiply and divide by x. So we will have 2x over x squared plus 3 over x squared. So I have a common denominator of x squared now. So we combine the numerators, so 2x plus 3 over x squared. The denominator (4 over x squared minus 9 over x). I need to get the common denominator of x squared, so I'm going to multiply and divide 9 by x, so x times x would be x squared. So common denominator is 4 minus 9x divided by x squared. So we have the numerator, we have the denominator, flip the denominator and multiply to the numerator to get the final answer. So 2x plus 3 over x squared. Flip the denominator, we have x squared over 4 minus 9x. The x squared will get cancelled. So we would have 2x plus 3 over 4 minus 9x. Okay, so I'm going to do the same process, numerator first, then denominator. Once you have enough practice, you're welcome to do it in any way that you like, as long as you get the correct answer. That's all that matters. So the numerator, we have 5 minus 3x. So I multiply and divide the 5 by x. So we have a common denominator of x null. So we can combine the numerators, 5x minus 3. The denominator has x plus 2 over 3x. The least common denominator that we need in order to combine the two terms would be 3x. So we multiply and divide by 3x. which would give us 3x squared plus 2 over 3x. Now we have the numerator combined, the denominator combined. All we have to do is flip the denominator and multiply it to the numerator. So 3x over 3x squared plus 2. The x's will get cancelled. So we have 3 multiplied by 5x minus 3 divided by 3x squared plus 2.
Wait, Professor, is it wrong?
Okay, so the next one is a bit of a challenging problem. So we have to do it one step at a time. So numerator, we have 4 over 5 minus x and 5 over x minus 5. And you may say, well, nothing looks similar between the denominators, but by all means, 5 minus x and x minus 5, they just differ by a negative sign. So if I put a negative out of the first denominator, I could write it as a negative 1 multiplied by x minus 5 plus 5 divided by x minus 5. But whether you have that negative 1 in the denominator or numerator doesn't matter. So I'm going to write it as minus 4 over x minus 5 plus 5 over x minus 5. I have a common denominator now, so I can combine the numerators. 5 minus 4 is 1 divided by x minus 5. So that's the numerator. The denominator, on the other hand, has 2 over x plus 3 over x minus 5. And if you look at the two denominators, they have nothing in common. So the LCD has to be x multiplied by x minus 5. So I need to have an x minus 5 in the first denominator. So I multiply and divide by x minus 5 to get the LCD. The second denominator has x minus 5 by itself. I need x, so I multiply and divide by x to get the LCD. Now that we have a common denominator, I can combine the numerators, distribute the 2, you get 2x minus 10 plus 3x, which simply gives us 5x minus 10 over x times x minus 5. I know we can simplify more, but I'm going to wait till the last step and then simplify now that we have the numerator and denominator sorted out. Take the denominator, flip and multiply to the numerator. So I have x times x minus 5 divided by 5x minus 10. So the x minus 5s would get cancelled. So we have x over 5x minus 10. Well, there isn't much of a simplification. Rather, you have a common term, a common factor, 5. So we can pull that factor out and write it as x over 5 multiplied by x minus 2. Okay, so numerator first, then denominator. So I'm going to start with the numerator. There is nothing in common between a plus 2 and a minus 2. So the LCD is a plus 2 times a minus 2. So we have to get the LCD of a plus 2 times a minus 2. So I'm going to multiply and divide the first fraction by a minus 2, the second by a plus 2. And we all know that a plus 2 times a minus 2 is a squared minus 4. So a squared minus 4. Numerator is 5a minus 10. Distribute the negative, we get negative a, negative 2, which would give us 4a minus 12 divided by a squared minus 4. I personally deal with common factors such as 4 in this case, and whatever simplification that I want to do until the very last step. I just save it for the very last step. So I'm just going to leave that as is and move on to the denominator. Three over 2 plus a is the same as 3 over a plus 2. And if I pull a negative out, I will have negative 6 over a minus 2. I'm doing this because I realized that the denominator term, the denominators of the denominator are pretty much the same as what we had in the numerator. So the LCD will still be the same, which is why I'm trying to pull, which is why I pull the negative out so that the LCD would still be a plus 2 times a minus 2. So I've got to multiply and divide the first expression by a minus 2. Multiply and divide the second term by a plus 2. So we have a common denominator of a squared minus 4. Combine the numerators. We have 3a minus 6 minus 6a minus 12, which would give us negative 3a and negative 18 over a squared minus 4. Now that we have the numerator and the denominator, we simply flip and multiply. So 4a minus 12 divided by a squared minus 4. Flip, we have a squared minus 4 divided by negative 3a, negative 18. The a squared minus 4 will get cancelled. Now I can pull the common term out, so I have 4 as a common factor between 4a and negative 12. So if I pull 4 out, I have a minus 3. In the denominator, I have negative 3 in common. So if I pull that out, I would have a plus 6. That is the same as saying negative 4 over 3, a minus 3 over a plus 6. So here we have one fraction divided by another, and there is no combining things here. If you go back and look at the previous problem, the numerator had a bunch of rational expressions and we tried to combine it and then simplify, but that business is not here. All I have to do is flip and multiply the denominator to the numerator. So I have negative 2x over x minus y. Flip, we have x squared over y. Negative 2x times x squared would be negative 2x cubed divided by y times x minus y. And that's it. Okay, So just like the previous problem here, there is no combining or simplifying the numerator, then simplifying the denominator. None of that to get the answer. So all we have to do is flip the denominator and multiply it to the numerator. But what we've got to realize before we write the answer out is there are things that we can get rid of. The easy one that we can spot right away is the y. But there is also an x that we can get rid of. In the denominator, the x squared plus xy multiplied by x squared. The x and x squared would get cancelled, so we would have 7x over y times x plus y. Okay, so this is a problem where we have to fractions in the numerator, a fraction in the denominator. So I'm going to do it separately. Numerator, I have 5 over x squared minus 2 over x. The common denominator between x and x squared is x squared. So I need an x squared in the second fraction, so multiply and divide by x. So 2x over x squared. The common denominator is x squared. Combine the numerators, we have 5 minus 2x. Moving on to the denominator, we have 1 over x plus 2. The common denominator is x, so multiply the 2 by x and divide by x, so we would have 2x over x. We have a common denominator now, so 1 plus 2x divided by x. So we have the numerator, we have the denominator, so the next step is to simply flip the denominator and multiply it to the numerator. So 5 minus 2x over x squared times x over 1 plus 2x. The x and the x squared will get cancelled, so we will have 5 minus 2x over x times 2x plus 1. Okay, so we still have two fractions over a fraction, so I'm going to do them separately. So the numerator, over 4 minus 4 over x, and there is nothing in common between 4 and x, so the LCD is 4x. So I need to get a 4x in the first fraction, so I multiply and divide by x. X times x is x squared divided by 4x. I need a 4 in the second denominator, so I'm going to multiply and divide by 4. Which would give us 16 over 4x. Now that I have a common denominator, I simply have x squared minus 16 divided by 4x. And of course, there might be ways to simplify, but I'm just going to save the best for the last. So I'm going to wait until I get to the answer, and then I would simplify. The denominator term is 1 minus 4 over x. The LCD clearly is x. So I need to get an x in the first term, which is 1. So I multiply and divide by x. Minus 4 over x, which would give me x minus 4 divided by x. Now that I have the numerator and denominator sorted out, all I have to do is to flip the denominator and multiply it to the numerator. So if I flip x minus 4 over x, I would end up getting x over x minus 4. Naturally, the x's get cancelled. And you'd end up getting that, but most people would want to just stop there, but you shouldn't stop there, because you have to realize that x squared minus 16 is a special product, and I could write that as x plus 4 times x minus 4 divided by 4 times x minus 4. Those two will get cancelled. So we have x plus 4 divided by 4. And as I mentioned, do not forget the parentheses. So what we have in this complex fraction is nothing different from what we had previously. Only here we have negative exponents. We have a raised negative 3 plus b raised negative 1 divided by a raised negative 2. The objective here is to write them as fractions so that the entire thing would look like every single problem or something similar to what we have done earlier. So what would a raised negative 3 mean? It simply means 1 over a cubed. Properties of exponents. B raised negative 1 is simply 1 over b. Divide the entire thing by a raised negative 2. A raised negative 2 is the same as saying 1 over a squared. Now you can see that we have fractions in the numerator, fractions. So the denominator part is easy. The numerator, we need to find the LCD. So we have 1 over a cubed plus 1 over b. The LCD is a cubed times b because there is nothing in common. So I need a b in the first fraction, so multiply and divide by b. And I need an a cube in the second denominator, so multiply and divide by a cubed. We have a common denominator, so that would simply be a cubed plus b divided by a cubed times b. Now, we rewrote the numerator and we have a cubed plus b divided by a cubed times b, and divide that by 1 over a squared. Now all we have to do is flip and multiply. So a cubed plus b divided by a cubed times b times a squared over 1. Here we could get rid of the a squared and the a cubed, leaving a behind, which would give us a cubed plus b divided by b as the final answer.